Hello viewers, today we'll do one particular topic from ISC Physics Optics chapter, and the name of the topic is lens maker's formula. Okay, now in order to derive the lens maker's formula, we have to first of all use a few symbols to understand what is the object distance and what is the image distance. Basically here you can see this is a convex lens, a biconvex lens of thickness t. Now for this bent surface, it has got two bent surfaces. For this bent surface, P1 is the pole and C1 is the center of curvature for this particular surface. Similarly, for the other surface, P2 is the pole and C2 is the center of curvature for this surface. Now, if you look at the drawing and follow the arrow, basically what is happening, the object is kept at this point on the principal axis, which is marked as O. So you can say that this much distance is the object distance U. From P1 to O, this much distance is the object distance U. Now, this ray of light is incident on this lens at the point A, and as a result of refraction, the outside this medium is, let's say the refractive index is N1, and the medium for the lens, suppose this refractive index is N2, and of course here again it is N1. Now at this point what will happen? Refraction will take place. As a result, light coming from the rarer medium entering the denser medium, it will be bent towards the line joining the point of incidence and the center of curvature. So as a result, it will be bent towards the normal and the light ray is bent. So instead of going straight like that, it is bent from A to B. Now in the absence of the second spherical surface, this light would have gone and it would have met over here at the point I dashed. So you can say I dashed is the image formed because of refraction at this spherical surface at the point A. But actually in reality, as you can see, there is one more spherical surface as well. So what will happen? A second time refraction will take place at the point B. So here I have joined B to C2. You follow this dotted line. This is the normal. So here again refraction will take place and light is going from the denser medium into the rarer medium. So it will be bent again and finally the ray of light is meeting at the point I. So we can say that I is the position of the image formed due to refraction by the lens, and O is the object and I is the final position of the image. So let us now assume that the final position of the image is at I. Let us assume that the distance of I from the lens is V. V is the distance, and the distance of I dashed from this point, that is P1, is, let's say, V dashed. Okay, so the object distance, that is the distance of object which is at O from P1 is U, and the distance of I dashed from P1 is V dashed, and the distance of I from P2 is V. Therefore, what will be the distance of I dashed from P2? It should be V dashed minus P. So this is the distance of I dashed from P2. I hope it is clear with everybody. What is V and how much is V, how much is V dashed, and how much is V dashed minus 2. Now let us apply the formula that we have learned before, which is called N2 upon V minus N1 upon U is equal to N2 minus N1 upon R. This is the formula for spherical refracting surfaces. We have done this before. Now we will be using this formula to find the image distance due to refraction at the first surface. As you remember, I told you there are two surfaces. One is this, another is this one. For the first surface, so you can say that for refraction at the first surface. For refraction at the first surface, we will be applying this formula. Light is going from the rarer medium into the denser medium. So what shall we write? We shall be writing N2 divided by V dashed. As you may recall that because of refraction at the first surface, the ray of light should have met over here at the point I dash. So that means the distance of I dash from P1, this is the image distance for refraction at the first surface. So we will say N2 by V dash minus N1 upon U is equal to N2 minus N1 upon R. Okay. But you should not write R over here because the refractive, the center of curvatures are different. Therefore, the radius of curvature will also be different for the two refracting surfaces. So what we'll say, we'll be saying that this is actually for this side refraction is taking place, and this is C2. Therefore, we can say this is R2. We can make it equation number 1. Now for refraction at the second surface. For refraction at the second surface. Now here what I will do, this image which is supposed to be formed over here I dash, this will be acting as the virtual object for the second surface. So what will be the object distance? The object distance will be from here to here, that is I dash to P1. Okay, so let's do. So you see, for the refraction at the second surface, what you have, N1 upon V minus N2 upon V dash minus T is equal to N1 minus N2 by R2. So here I will tell you light is coming from the rarer medium and entering the denser medium. Rarer to denser medium when the refraction is taking place, then this I dash is acting as the virtual object. So virtual object, and the distance of this point I dash from P2 is V dash minus T. That's why in place of object distance you are writing V dash minus T. And the image distance is V because the final image is formed over here because of refraction of the second surface. That's why image distance you are writing V over here, and N1 minus N2 by R2. R2 is the radius of curvature of the second surface. So this is R2, and here this will be R1. Okay. Now if we look at these two equations, basically they can be combined together. But before we do that, let us recall that the thickness of the lens is taken as T. For very thin lens, here basically we deal with thin lenses. So for a thin lens, T is very small. T is very small. The thickness T is very small. When the thickness T is so small, then this V dash minus T, this will be approximately same as V dash only. So I'll be writing the next line. I'll write it over here. Okay. So you can say that N1 upon V minus N2 upon V dash is equal to N1 minus N2 upon R2. We can make it equation number 3. Now if you add these two equations, equation number 3 and equation number 1, what do you get? This N2 upon V dash will get cancelled. So basically after adding this equation number 3 with equation number 1, we get N1 upon V minus N1 upon U will be equal to N2 minus N1 within brackets 1 upon R1 minus 1 upon R2. This is what you get. I hope you understood this part. After adding we get this much. Now from this entire equation you can copy, or you can take out common N1. So when you take out N1, what do you get? 1 upon V minus 1 upon U is equal to N2 upon N1 minus 1 upon R1 minus 1 upon R2. We get this. Now N2 upon N1 you may recall, this is nothing but refractive index of the second medium with respect to the first medium, and this can be written as just n. N is equal to n2 upon n1. So that way we get 1 upon v minus 1 upon u is equal to n minus 1, 1 upon r1 minus 1 upon r2. So 1 upon v minus 1 upon u equal to n minus 1, 1 upon r1 minus 1 upon r2. Now here we will be considering one special case. Special case means when the object is at infinity. That means when the object is very far away, then what happens? The image will be formed at the focal point or the focal plane. This you have done in the lower classes. So let us apply that assumption that if the object is at infinity, then the image will be formed at focus. So if you write it over here, then what you get? 1 upon f minus 1 upon infinity is equal to n minus 1, 1 upon r1 minus 1 upon r2. That is 1 upon f is equal to n minus 1, 1 upon r1 minus 1 upon r2. So we get this final relation. What you need to do is we need to compare now. So if you mark this equation as equation number 4 and this one as equation number 5, then these two equations if you compare, then what do you get? After comparing we can write, after comparing this number 4 with number 5, we can get 1 upon v minus 1 upon u is equal to 1 upon f. This is the most familiar equation for lenses, and this is valid, this is true not only for convex lens, this is also true for the concave lens as well, and this is also the final form of the lens maker's formula.